Okay, on this word problem, we're given an exponential function, and it represents the number of bacteria in a culture at a given time, where t is going to be in hours. And most of this is just about reading and interpreting the different numbers and components of this function and understanding what it means. So what I've done is we've been given the function n of t. I've also laid out a of t, which is our continuously compounded interest formula, because basically everything lines up, and this is a formula you may have seen be more comfortable with than the new exponential functions. All right, so in this case, P is the initial amount that we invest. We call that the principal in banking problems. So it's going to be how much you start with at basically time zero. E is a number in both of these. R is our rate, and T is our time. It's our variable that's being plugged in. It's our input value. Okay, so when we're trying to answer these questions, we want to know what is the relative rate of growth for this bacterium population. So that rate is going to correspond with whatever rate we have in the exponent. So in our case, we can say that's 0.25. It's positive, so things are getting bigger over time. It's increasing over time, and that's it written as a decimal. We should also be able to rewrite this as a percentage. To do so, we would want to move 2 decimal places over to the right-hand side. 25% corresponds with 0.25 as a decimal. All right, next, the initial population of the culture. That corresponds with how much you start with, like our principal is going to match up with where that 900 lies in our formula that's given to us. So we can say we have 900 bacteria in this culture at the very beginning. Another way you get this, if you're not as comfortable just yet, is we could evaluate our function n 0 hours into this. So that would be 900 times e raised to the 0.25 multiplied by 0 up in the exponent. Now our new exponent as we work this down is going to be 900 e to the 0 power, and anything to the 0 power is equal to 1, so this is really 900 times 1, which is a much longer way to get to 900, all right, than just identifying, oh, it's the number out in front that's being multiplied by the e to the power, but you can get there the same way either direction. All right, and the final question on this, how many bacteria will the culture contain at time t equals 5? So for this one, we're going to evaluate it. We're going to go n of 5. We're going to replace each of our t's with 5s. So up in the exponent, we're going to be multiplying 0.25 by 5. Now we could do some simplifying down, but we're probably going to get the calculators out along the way and get those to do most of the work for us. All right, so the E button on our calculator tends to be above the natural log, the ln button, so you usually have to push 900 and then second natural log. That should bring up the E raised to the power, enter in that exponent, maybe close off some parentheses and press enter. I got this to be 3141.308662 came out on my calculator. Now, being that these are bacteria, let's round to the nearest integer value, the nearest whole bacteria. So what I'm going to do is go ahead and drop off all these decimals at the end and leave 3,141 bacteria after 5 hours time. All right, hope this helps out as you're getting used to the components of exponential functions. Good luck.